TriHack Dojo and the SEC-1 certification series. In this session, we'll develop the structured understanding of the OSI model, TCP versus UDP, the TCP Three-Way Handshake, data encapsulation, and how attacking map exploits to user layers. This is not a theoretical knowledge for memorization. This is a operational knowledge required for ethical hacking and penetration testing and network security analysis. So first we'll understand why networking is the foundation of cybersecurity. Every cybersecurity is transmitted over a network, whether it is a reverse shell, a malicious HTTP request, a command injection payload, or a DNS amplification attack. It must traverse network infrastructure. Routers forward it, switches frame it, transport protocols manage it, application interpret it. If you do not understand how data moves, you cannot properly analyze, detect, or exploit vulnerabilities. Networking knowledge transforms random tool usage into structured offensive strategy. Next, we'll understand what is the OSI model. The OSI stands for Open System Interconnection, or OSI model. It's a 7-layer conceptual framework that standardizes the network communication. It divides communication responsibilities into discrete layers. Each layer performs a defined function, adds a specific metadata, introducing unique vulnerabilities. For security professional, the OSI is a tactical map. It allows you to identify where data is processed, where control is enforced, where weakness exists. The 7-layer OSI model. So the layer 7, that which is an application layer. The application layer interface directly interact with the user level services. Example, HTTP, FTP, SMTP, or DNS. These layers processes requests and generate responses. Security implications. Most web application attacks occurs here, that is SQL injection, cross-site scripting, command injection, remote code execution. These attacks exploit application logics rather than transport mechanism. Next comes the layer 6, which is a presentation layer. The presentation layer is responsible for data encoding and decoding, encryption and decryption, and last one is compression. This is where SSL, TLS operation logically occur. Security consideration includes weak cipher suits, improper certification validation, encryption downgrade attacks. If encryption is improperly implemented, confidentiality is compromised. The next comes the layer 5, which is the session layer. The session layer manages logical sessions between the hosts. It establishes the connection, maintains synchronizations, terminate communications. Security vulnerabilities include session hijacking, session fixation, token reuse. Compromising these layers allows attackers to bypass authentication mechanism. Then comes the layer 4, which is the transport layer. The transport layer ensures end-to-end communication between the host. It manages port numbers, reliability, flow control, error corrections. Two primary protocols operate here, which is the TCP and the UDP. This layer is critical for network reconnaissance and denial of service attacks, that is DDoS attacks. Next comes the layer 3, which is the network layer. The network layer handles logical addressing, which is IP addresses, routing decisions, packet forwarding. Routers operate at these layers. Common attack techniques include IP spoofing, route injection, DDoS amplification, leveraging IP. Understanding packet routing is essential for tracing and obfuscation analysis. Then comes the layer 2, that is the data link layer. The data link layer manages MAC addressing, frame construction, local network switching. Switches operates at this layers. Typical attacks include ARP poisoning, MAC flooding, VLAN hopping. These attacks enable local network intersections and lateral movement. Then comes the layer 1, which is the physical layer. The physical layer transmits raw bits over the physical medium. It includes copper cables, fiber optics, wireless radio signals, network interface hardware. Physical attacks may include hardware taping, signal interceptions, unauthorized device insertion. Through often overlooked physical compromise can bypass logical defenses. The choice The choice between TCP and UDP determines reliability, speeds, and exploitability. Now let us understand the TCP, that is Transmission Control Protocol. What is TCP? TCP is connection oriented, reliable, ordered, and stateful. It establishes the communication through the three-way handshake. The characteristics are guaranteed delivery, acknowledgement based communication, packet sequencing, congestion control. Because TCP maintains the state, it is susceptible to sync flood attacks, session hijacking, TCP reset attacks, advanced port scanning techniques. Understanding TCP state transition is essential for crafting transport layer exploits. Now let us understand UDP, which is the User Datagram Protocol. UDP is connectionless, stateless, faster than TCP, no delivery guarantees. It does not perform handshake, acknowledgements, retransmission. Because of its stateless nature, UDP is heavily used in DNS, VoIP, Voice over Internet Protocol, streaming services. Security implications include DNS amplification attacks, UDP reflection attacks, DDoS leveraging spoofed source IP addresses. UDP's lack of verification makes it ideal for high volume amplification attacks. Now let us understand how TCP works, which is how TCP works and how the three-way handshake works. The TCP handshake establishes the reliable communication. So the step one is the client sends a synchronization request with an initial sequence number. Step 2 is sync acknowledge. The server acknowledges the client sequence number and send its own. Step 3 is acknowledgement, that is add packet. The client acknowledges the server sequence number. Connection is now established. Attacker exploits this mechanism using sync flood attacks. By sending numerous sync packets without completing the handshake, the attacker forces the server allocate resource for half open connections, leading to resource exhaustion. Now let us understand data encapsulation, or how information travels. Data transmission follows a structured encapsulation process. Each OSI layer adds its own header. The process follows this hierarchy: application layer, transport segment, network packet, data link frames, physical bits. On the outgoing path, application generates data, transports add port numbers, networks add IP addressing, data link adds MAC addressing, physical converts to electrical or radio signals. On the incoming path, each layer removes its corresponding header until the application receives the clean data. Security relevance. Understanding encapsulation enables packet crafting, traffic manipulation, man-in-the-middle attack, deep packet inspection. Without understanding the encapsulation, packet level exploitation is not possible. Mm, Now let us understand where hackers strike layer by layer, or understanding the attack surface mapping. Security professional must map exploits to layers. Layer 7, which is application attacks. Layer 4 is the transport attacks such as sync flood. Layer 3 is IP spoofing and routing abuse. Layer 2 ARP, address resolution protocol poisoning and switching manipulation. Layer 1 is physical interceptions. Effective attackers think in these layers. Effective defenders monitors in layers. Key takeaways. The OSI model provides a structured framework for analyzing attacks and defenses. TCP and UDP serve the different purposes. Reliability versus speed. Each introduces unique vulnerabilities. The TCP handshake is fundamental to understanding transport layer exploitation. Encapsulation explains how data is structured, where interception is possible. Each layer specific knowledge enables precision is both offensive and defensive operations. So in this next session, we'll explore IP addressing, subnetting essentials, and how logical addressing enables both routing and exploitation. Understanding IP structure is critical for reconnaissance and network mapping. This is Try Hack Me Dojo SEC-1 certification series. Continue building your foundation, master the layers, master the network, master the cybersecurity. Till then, see you in the next session.